Well, here we are looking at compounds which I've said violate or exceed the octet rule for the number of electrons around the central atom. Now, if you were in class, we've talked about this. If not, perhaps you've read in your textbook that some compounds are going to exceed the octet rule just because of the number of other atoms bonded to the central atom. Now, we talked a little bit about, and maybe you've read about this thing called hybridization theory, which says that that central atom may take, in some cases, s orbitals, p orbitals, and d orbitals and mix them all together or hybridize them into a set of orbitals that have some s character, some p character, and some d character. So it's not a pure s, a pure p, or a pd, but I'm sorry, a pure s, a pure p, or a pure d orbital, but is a set of orbitals that all of which have some s, p, and d character to them. Unfortunately, we don't have time in Chem 104, Chem 111 to go into depth about that. It's a very interesting theory, very interesting way of explaining how this bonding occurs. And perhaps if you go on and take more chemistry, you'll dig deeper into that. Now, what we're going to do, though, is we're going to follow our rules, just like we've been doing, to draw these compounds. So, our first one here is SF6, sulfur hexafluoride. So let's go through our steps again and see how this all works out. So, I scan the formula again, no hydrogen, so each of those atoms needs 8 electrons. So I see 1 sulfur and 6 fluorines, so I see 7 atoms up there, each of which needs 8 electrons. All right. So 7 times 8 is 56 electrons are needed. All right. Now available, remember we're going to go to group number, so I have 1 sulfur in group 6, so it's bringing its 6 valence electrons to bond, and I have 6 fluorines over in group 7, so they're each bringing 7 valence electrons. 6 times 7 is 42, and 6 more is 48, so I have 48 electrons to work with that I'll have to assign in my final structure. Shared, all right, N minus A, so 56 minus 48 says that I have to share 8 electrons. And so bonding would be the shared number divided by 2. So my formula has to have 4 bonds. All right. And if I'm going to pick a central atom, fluorine is the most electronegative element in the periodic table. Therefore, sulfur will have to be the central atom, and it's the only one of its kind. So we're going to come over and draw sulfur. We're going to draw 6 fluorines around it in some symmetrical pattern. Now, here's the thing. You cannot add fluorines, and you certainly can't get rid of any fluorines from that formula. The formula says there's 6. You need to show 6 in your compound. So we've put in our central atom. We've put our 6 fluorines around it. Our next step said draw a single bond to everybody, from the central atom to each of the outside atoms. All right. I have used 6 bonds. This thing said I had to show 4, so this is where we've started having a trouble with that. Okay. Now remember what your book says about bonds. That's the minimum number that we're going to show in the formula. We have to show that many. The fact that I've already shown 6 says I obviously have exceeded the 4. I won't have any double bonds, that's for sure. All right. The bonding tells us how many we have to show, and it's good for telling us if we have to have multiple bonds, like doubles or triples. But it will break down in this case because we can already see 6 fluorines had to be bonded around there, so that sulfur had to have 6 bonds to it. All right. Now we're going to go back and assign 48 electrons, starting with the fluorines. Each fluorine already has 2, so we're going to give each fluorine 6 more. So go ahead and do that on your sheet that you're working on right now. While I painstakingly put in 6 electrons on each one of these fluorines. All right. Some of those don't look like too big. All right. So we've done that to each of the fluorines on the outside. So let's see how many we've assigned. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48. I've assigned all 48 electrons. All the fluorines are happy. They have their 8 electrons. And sulfur, if you look at it, has 12 electrons. That's okay. That's all right. It's what we say expanded its valence shell. And remember, sulfur is sitting, it's in the 3rd period. Right? And what orbitals are available in the 3rd period? Well, we have S's and we have P's. And if you remember, the first d orbitals are in the 3rd period. So that's what we think is it's using a combination. It's hybridizing the S, the 3 P's, and 2 of the D's to make a 6, what we call D2, sp3 hybridized orbitals. Okay? 1, 2, 3, 4, 5, 6. Each of those orbitals is what we call a D2sp3. It's not a pure S, not a pure P, or not a pure D. So that's how we've done that. So what I need you to do next is try one of these on your own. And so what I want you to do is try PCl5, phosphorus pentachloride. I want you to go ahead and practice that one and put this on pause while you do that, and pull up the next slide when you come back and check your answer against mine. We'll walk through it quickly. Okay. Hopefully you are back and have had time to draw a good Lewis dot structure for PCl5. Doing your needed count, no hydrogens, so 6 atoms of phosphorus and 5 chlorines times 8. 6 times 8 is 48. Available, 1 phosphorus in group 5, so 5 valence electrons there. 5 chlorines in group 7, so 7 valence electrons per chlorine. 5 times 7 is 35, and 5 more is 40, so we have 40 to work with. Shared, 48 minus 40 would be 8 electrons. And bonds would be the 8 electrons divided by 2, saying 4 bonds. Our central atom's got to be phosphorus. It's the only one of its kind, and it's less electronegative than chlorine. So you put phosphorus in the center. You put your 5 chlorines around it in a symmetrical pattern, and then you started assigning. You assigned single bonds to everybody. You assigned 5. Your calculation said you had to show at least 4. You've done that. So you're not going to have any multiple bonds. You began to assign your 40 available electrons to the chlorines. Each chlorine already had 2, so you gave it 6 more. When you got done with that, you counted, and you found out that you had used 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. You'd used all 40. Each chlorine had 8. That was good. And the phosphorus ended up with 10 on it. But that's okay, because phosphorus is in that 3rd period, and so could have more than 8 electrons around the central atom. So hopefully you've got that. We understand how to go about that. And you'll be able to draw one of these on some future exercise if you're called on. All right, well, that's going to end this video, and we'll see you in whichever video you're going to watch next.